Adding and subtracting polynomials. Today we're going to define expression, term, factor, and coefficient. We're also going to be able to add and subtract polynomials. Looking at some examples down here, 1 through 5, these things are all called polynomials. So this first thing is 6. This is really 6x to the 0 because there is no variable there, so it's really whatever variable you'd like to the power of 0. That's why it's a 0 degree. Number 2, 5x plus 9 is a polynomial, and this is really x to the first, so that's a first degree polynomial, which makes it linear. 4x squared plus 7x plus 3, this is an exponent of 2, so that would be a second degree. Number 4, third degree, because there's a cube in there, and number 5 is a fourth degree, which is sometimes called a quartic. So degree is the highest exponent in that polynomial. So again, this is a 0, so it's called a constant. A 1 is called a linear. A square is called a quadratic. A 3 is called a cubic. And a 4 is called a fourth degree. And sometimes that word is also used as a quartic. So that is by the highest exponent. The other thing we'll talk about is the number of terms. So 1 term is a monomial, 2 terms is a binomial, 3 is a trinomial, 4 or more terms is just called a polynomial. So looking down here, if we cover this part up, question number 1, there is 1 term there, so that's called a monomial. Number 2, there are 2 terms in there, the 5x and the 9, so that's called a binomial. Number 3, there are 3 terms, so trinomial. Number 4, there is 1 term, so that's called a monomial. And then number 5, this is a trinomial. So again, naming by the number of terms, we just count how many pieces there are. A monomial is a real number, a variable, or a product of a real number and a variable. Here are some examples of a monomial. A polynomial is a monomial or a sum of monomials. The prefix poly means many. An example of a polynomial is 3x, 3x to the fourth, plus 5x squared, plus negative 7x plus 1. There are 4 terms here, so this is called a polynomial. The degree of this polynomial would be to the 4th power, because that's the highest exponent. Standard form is very important. Polynomials are written in standard form so that the degree of the monomial decreases from left to right. The constant terms have a degree of 0, so they will always go last. So looking at question A, is this in standard form? Notice the x squared is first, the x term is second, and the constant term is third. So yes, this is in standard form. And the highest degree is 2, which would make it a quadratic. Letter B, is this in standard form? No. We would need this term to be in the front, so we'll rewrite it. Negative 12x to the fourth, x cubed will come next, so plus x cubed, and then this term will come next, a negative 3x. So our degree here is a 4. So we just call that a 4th degree or a quartic. So let's take these 4 and rewrite them in standard form, and then we'll classify them. Number 11, squared would come first, so negative a squared. The a term would come next, plus 7a, and the constant always goes last. Number 12 is already in standard form. Notice we have a b and an n. So because this is the highest exponent, it'll go first. If they were the same exponent, then it would go alphabetic. So if our question was 5b squared plus 2a squared, this would have to be rewritten as 2a squared plus 5b squared. Because then we go highest exponents and then we go alphabetic. Number 3 is already in standard form. Number 14 needs to be simplified. So x cubed is our highest, that goes first. Then we go down to x's. Those two simplify, so I get negative 2x. And then my constants combine to give me negative 1. So now let's go back and name each polynomial based on the degree and number of terms. So this is what we're thinking about. Number 11, the highest exponent is a 2, which makes it a quadratic. It has 3 terms, so this is called a quadratic trinomial. Number 12, I see a second degree, a highest exponent of 2, and I see 2 terms, which makes this a quadratic binomial. On the bottom, I see 1 term, 4th degree, makes it a quadratic monomial. Number 14, 3rd degree, 3 terms, a cubic trinomial. Try the next 5 questions, checking to see that they are in standard form, and then name them by degree and number of terms. Pause the video till you're ready. Number 4 was the only question that had to be put in standard form. Double checking our answers. Number 1 is a quartic binomial. Number 2 is a linear monomial. Number 3 is a linear binomial. Number 4 is a quadratic trinomial. And number 5, there is no variable, so this is called a constant 1-term monomial. Let's review some vocabulary. A term is each monomial that's in a polynomial. So looking back over here, our terms was each part of the polynomial. So if it's separated with addition or subtraction, that is a term. The number that is multiplied by a variable is called a coefficient. So looking back, our coefficients were the 7 and the 7, the 3, the 2, and the 5. So it's the number that goes with the term. That's the coefficient. So when you're adding or subtracting polynomials, you add or subtract the like terms by adding or subtracting their coefficients. So looking at this, the coefficient here and here is negative 6 and 11. So when I add those numbers together, I get 5. And then I would keep the x to the 4th the same. So I want to add or subtract their coefficients. So again, 2, and then I'll consider this to be a negative 7, because the x squared y to the 4th, x squared y to the 4th is the same. So this is a 2 minus 7 gives me a negative 5 x squared y to the 4th. In previous lessons, we just call this combining like terms, where if this, I consider it to be a label, is the same, then you can add the coefficients. So over here, we have a trinomial plus a binomial. So the parentheses really don't have a role in this question. So I could rewrite it if I want, or I could just work with what the problem has. So now I'm just finding my matches. T to the 4th does not have any matches, so I'm going to write that out front, because this has to be in standard form. Then I'm looking for cubes. There's the only cube, so I'll write that next. Then I'm looking for squares, so minus 4t squared. Then I'll go to my t, and then my constant plus 9 goes last. So like terms here, there aren't any, so they all have to be written separately. Question number 3. This is subtraction. So we have a binomial subtracting a trinomial. So this negative sign really plays a part. So I'm going to rewrite this, leaving the binomial alone. But what's happening here is you can consider this to be a negative 1, and it needs to be distributed to each term. So this becomes plus 5k cubed minus 3k squared plus 8k. So what happened is the signs of every term had to change because we had to subtract each term. Subtracting a negative made it positive. Subtracting a positive made it negative. Subtracting a negative made it positive. Now we simplify and find our matches, or our like terms. So I get -1 k cubed, moving on to k squared for -3 k squared, and then a k and a k make 11k. Find this problem. Trinomial minus trinomial. This is what it would look like if we rewrote it. We have to subtract this trinomial, so every number inside here would have to change sign. So we get a -7x cubed, -5x squared, +12. And now we can find our like terms. Highest exponent goes first. Then we go to squares. And our constant always goes last. The next couple of questions add in an application. A pizza shop owner is monitoring the amount of cheese he uses each week. The polynomial below models the pounds of cheese ordered in the past week, where P represents pounds. So we have mozzarella and cheddar. Write a polynomial that models the total number of pounds. So that's telling me I want to add these. So what I'm going to do is look to find my matches. P squared, P and P, constant and constant. Then I'm just working on adding my coefficients together. My P cubed goes by itself. -6 and 12.5 give me 6.5. 14 and 18 give me 32p. And my constant is 200. In the next question, write a polynomial for how many more own than rent. So in this one, we want to subtract. So that means this becomes negative, becomes negative, becomes negative. So 4 minus 6 gives me -2. 360 minus 125 gives me 235. 22,178 minus 5286 gives me 16,892. This concludes my video.